My name is Gray, and I'll be talking about robot freedom, in particular ROS, Gazebo, and open source software in robotics. So a little bit about me. I was already introduced, but I finished my PhD in robotics about 3 years ago. I work at an open source software company, and I've been contributing to and benefiting from open source software for about 8 years now. You'll notice that some of these terms are in quotes. I'm going to be elaborating on my definition of those 3 things throughout this presentation, which is why they're in quotes. So, first question that I'd like to discuss is, what is robotics? Right, robots mean, like, robotics and robots kind of trigger different ideas, different concepts for a lot of different people, often inspired by sci-fi. So I just want to start by nailing down, like, what do I consider robotics to be?
Sorry
from
to
my
interrupt. There is a little bit of noise coming in the mic.
Really? I don't. Is it like a?
It's like
no.
It's
Maybe
like your voice is crackling, like it's cracking in.
Oh, crackling.
Yeah.
Could that be a network, like an internet problem?
Might be, like it's happening for all of us. So yeah.
Oh, okay. I don't think there's any ambient noise.
You are sounding like a robot. It's like something.
I'm sounding like a robot. Yeah, that's probably a bandwidth issue then. Okay, let me just double check my network settings. Make sure I'm not on Wi-Fi or something. So no, I should be on Ethernet right now. So I'm afraid this is probably as good as it's going to get. Yeah, I'm not sure if there's anything I can do about that. Is it devastating?
It's a bit like irritating.
Okay.
But it's audible.
Maybe if we can change the microphone somehow. We can try.
No, this mic, it's a really good microphone in terms of hardware.
Okay, so we can continue. Okay, we can continue.
Okay, yeah, sorry about that. Let me maybe stop my video. Maybe that'll improve the bandwidth, and maybe that'll help with the audio. Let's see how that goes. It's no better?
The audio is same.
Audio is the same?
Yeah.
Okay.
So I think it's not.
So Michael, it's not a problem. So we can continue. You can present your screen, and we can continue without.
Okay.
Yeah, it's understand.
Okay. Yeah, just
it's audible.
Yeah, grit your teeth, folks. Sorry about that. Okay. So what is robotics to me? Well, fundamentally, it is engineering. Robotics is about engineering. But what kind of engineering? Because there's a lot of different kinds. So there's mechanical engineering, because some robots have arms, and some even have legs, and some have whatever this thing is. I don't know. Is that an arm? Is it a mouth? A neck? I'm not really sure. But it's pretty cool, and I guess it can be useful, right? So whatever it is, though, it's very mechanical. And if you want to have something like that on your robot, you've got to be pretty good at mechanical engineering. What else is robotics? It's control systems, because this is what happens if your control system is not good enough. You need to be able to make really good control systems for your robots, otherwise this happens. Mechanical engineering is not enough, because these robots that you see are absolute masterpieces of mechanical engineering. I mean, so this video is from about 5 years ago. And these were like the best robots in the world, the most advanced mechanical designs in the world. But without a good enough control system, they can't actually do much. Boom. And this is a lot of money, guys. This is a lot of money crashing and burning with every single one of these falls. Very expensive. This video is very expensive. All right, so what happens when you do have good control systems? You can get stuff like this. So like this is arguably the best control system in the world, developed at Boston Dynamics. Super impressive. Boston Dynamics, I'm sure you guys have seen, they put on amazing videos, and they really have the combination of incredible mechanical engineering and incredible control systems engineering to thank for that. Okay, so what else is robotics? It's networking. These days, multi-robot systems are becoming very, very popular. There's a lot of economic incentive to be able to just cram a bunch of robots into one place and have them do useful work. But for your robots to actually do that useful work, not only do they have to have good mechanical design and good controls, but they need to be able to communicate with each other or with servers or something. So the networking is extremely, extremely important in modern day robots, and it's going to become even more important over time. That's the trend that I'm seeing in the industry is people just want lots of robots in their facilities, and they all need to be good at talking to each other. All right, what else is robotics? Vision and perception. If you want your robot to be able to get around in the world, it needs to be able to see things and to understand what it's seeing, or feel, if you prefer other kinds of sensors. But your robot needs to be able to perceive. So at the top, there's a point cloud. That's a very popular way to just kind of get a sense of what's taking up space in your environment. So you don't necessarily know what the things are, but you know that there is a thing there. And then at the bottom, you can see some object recognition happening. This is probably using almost certainly using machine learning. And it's identifying that there's a bunch of cars, and then it sees the bicycle, and it sees the person on the bicycle, and it's able to create this semantic understanding of what the sensor data is providing. Okay, what else is robotics? Artificial intelligence, my favorite. All right, so robots need to be able to move around through the world if they're mobile. They need to know how to get from point A to point B. And they don't always do, the most efficient job, but they need to be able to get there. Right? And here you can see a robot cheating at tic-tac-toe. Look at those shifty eyes, it knows what it's doing. And then there's all sorts of more sophisticated AI that usually exists in simulation, but maybe can be ported over to the physical world. So up top, we see these robots playing this, simulated agents playing this competitive game with each other, using some simplification of physics. And then at the bottom, we see a robot learning to walk. It's not quite the same as a human baby learning to walk, but there's some similarities, right? Okay, what else is robotics? Human interaction. Some robots need to be able to interact with others, either for like telepresence robots, or there are even robots whose specific design is to make people feel good. To sort of inspire emotions in people. So the seal up here was actually designed for the elderly to sort of give them a companion. Okay, so robotics is all of these things, often all at once, all together. So my final answer to this question of what is robotics is it's really, really difficult and very complicated, right? These are, these 6 starbursts are each their own entire expertise. Like you can get a PhD in any one of these 6 things. You can be a world expert in any one of these 6 things and you'd be considered brilliant. But to be a roboticist, you usually have to have a pretty good handle on at least 2, preferably 3 of these topics. If you're really good, maybe 4 or more. But usually people get stuck at around 3. So it's really hard, and usually one person just cannot do it alone. It's generally just not feasible because of the sheer difficulty and complexity. So it's really, really difficult and very complicated. So what can we do about that? Historically, robotics was only used by large companies that had a lot of resources. So companies that could hire a lot of very talented engineers to work on these really tough problems. Robots would only be deployed in extremely controlled settings. So, no people around that might make a mistake that the robots weren't programmed to be able to deal with. So we're talking warehouses, back rooms, factory lines. For decades now, most robots are literally put into cages. And if you open the cage, then the robot just turns itself off, because otherwise, if a person steps in, then that person might get just killed by the robot. So robots historically have been very contained and very limited in their use. And on top of all of this, robots are very expensive. So even if you have expertise in any number of the 6 fields that I mentioned earlier, it's still going to cost you a lot to actually have a robot that you can use to research with. All right, and now what can we actually do about that? So I work for Open Robotics, formerly known as Opensource Robotics Foundation, now expanded to Opensource Robotics Corporation, and now we have a Singapore office, so there's like even more structural complexity there. But the overall organization we refer to as Open Robotics. That's like a catch-all term for our whole structure. So we are an open source software company, and we offer 2 major products, ROS and Gazebo. These are both 100% free, 100% open source software products. ROS is a middleware for robotics, while Gazebo is a simulator for robotics. So what is a robotics middleware? What is ROS, basically? So ROS allows communication between different processes in a computer. It also allows communication between different robots or computers or devices or servers. Now, on the surface, that probably doesn't sound all that relevant to robotics. I mean, this is an entire description of ROS, basically. It allows communication between different components. So you might be thinking, well, how does that help me build a robot or do robotics or anything? Like, how is this different from, making a web server or something and just talking over WebSockets? Well, if you design a robot in a way that we would consider good, you'll probably have some kind of node structure like what you see here, where you have a bunch of different specialized isolated nodes that are connected together through some kind of communication protocol. So in your firmware, so literally the physical hardware of your robot, on the embedded microchips, you're going to have like motors, sending and receiving information. You're going to have cameras and LiDARs and IMUs. All of these devices will need to send and receive data. And on your robot computer, you're going to want to have nodes that know how to process that data and do useful stuff for it. So like your sensor data will want to go into some perception nodes that do some computation, and then that will help your robot to localize itself. Localization, for anyone who doesn't know, just means the robot figures out where it is. It's kind of like if you pull out your phone and look at Google Maps and see what your GPS location is. Robots need to be able to figure out for themselves where they are based on sensor data. So you'll talk to your localization node, and then your localization node might talk to some kind of control node that figures out, like, okay, given where I am, how do I get to where I need to be? And then that control node can talk to your motors, and maybe these things will talk to your AI planner that might be, you know, the head honcho decision maker. And maybe that planner lives on some other server. Maybe your robot isn't even making, you know, decisions for itself. Maybe its real brain is on some totally different computer. And maybe over there is where the humans have a GUI that they can use to, you know, express to the robot what kind of tasks it needs to do. And all of these different nodes can be, will serve its own specialized purpose. And each node will exist as a separate executable. So these nodes, there needs to be some kind of inter-process communication or inter-device communication. And the important thing about this is that each node can be developed separately from the others, and each node can be developed by its own expert. So a control systems expert can develop the control node, a vision expert can develop the perception nodes, an AI expert can develop the planner node, electrical engineers can develop the firmware, and each node can be designed to be reused across many applications. And they can be designed for user friendliness. So even though an expert created the node, they can design it in a way that other non-experts might still be able to plug it into their robot system. So add all this up, and what do we get? The result is a global community of open source software packages written by leading experts in the various domains of robotics. So even though what ROS is fundamentally is just a way to push data around, and it's, you know, a little bit specialized for robotics, the result of its very existence as an open source, as a free open source software package is, well, I should say software framework to be technical, but the result of its very existence is we get a global community that builds on top of this framework that will share their various implementations of all these very difficult nodes and modules. So here are some examples of open source software that's been integrated with ROS in various ways. Now, most of these are not inherently ROS-related software. Most of these are developed independently of ROS, but they also provide integration with ROS, like as an add-on, as an optional way to use them. So if you are building a ROS system, then all of these different software packages have like ROS-ready modules that are ready to be plugged into your robot system. So free software is nice, but what about the cost of robots, right? So even if you get all this free software, we can throw all the free software in the world at you. it's still going to be really tough to be a roboticist, because how do you be a roboticist without a robot? And if you don't have money, like a lot of money, usually it's pretty tough to have like an actually useful robot. So how about free robots? Is that possible? Can you download a car? Can you download a robot? Well, the answer is you actually can. We also provide a simulator for robotics. So what Gazebo does is, going back to the robot diagram before, this firmware part, this represents like the robot hardware. We can swap that out for simulated nodes. So Gazebo will pretend to have motors. It will pretend to have a LiDAR, pretend to have a camera, pretend to have these different sensors. And all of these nodes will send and receive messages in the same exact way that the actual hardware would. So all these other nodes that you might work on will work just the same if you want to use them on a Gazebo simulated robot as they would if you tried to use them on an actual physical robot. So here's some examples. So this was part of a space challenge. This was a simulation competition where contestants basically had to teleoperate a humanoid robot that was on Mars. And for the competition, you would actually simulate the delay, the communication delay that would actually exist if you tried to control a robot on Mars. So the software that the contestants develop needs to be prepared for that delay. They need to design their teleoperation in a way that can cope with the huge delays between Earth and Mars. So typically they try to make their robot as autonomous as possible and require as little human intervention as possible. So the contest involved interacting with various objects and various tools. Right here, this is scanning for a simulated microfracture. So the tool that it just tossed on the ground there was scanning for the existence of a crack. And Gazebo was simulating scanner data. And now it's using a tool to repair that microfracture, the simulated microfracture. And yeah, just kind of dropping tools on the ground because I guess there weren't any points awarded for being nice to your tools. So just drop it. Okay, and right now we've been working on a subterranean challenge. So in this challenge, we've simulated some very deep and complicated cave networks. And the challenge is to have robots explore these caves and find various artifacts. And the contestants will get awarded points for the artifacts based on like how hard they are to find in the cave and where they're located. And so everything you're seeing here is a simulation in Gazebo. They're just kind of panning through the environment. And it goes on and on and on. Okay. We can also simulate autonomous boats. Let's see this. No, but sorry, let me get back to here. Okay. So we've got some water kind of waving. Let's see. I think there's a boat simulation shown somewhere. Oh yeah, here we go. So, so here we see this boat has buoyancy. You can see it kind of bouncing on the water there, and it's drifting because of waves and because of currents. And this is all in the same simulator as the other robot and subterranean environment. And you get this, so we get this kind of flexibility in the simulation by being a plug-in based simulator. So in order to get this buoyancy and this drifting, someone, well, I think us, wrote a plugin to sort of tweak the physics of the simulation so that these boats will float and will drift and stuff. And so you can write your own plugins to change the way the physics behaves in Gazebo. And you don't have to change anything about the existing software of Gazebo. You can just, I mean, you could if you wanted to, you can fork Gazebo and rewrite it for your own purposes. But forking is usually a bad idea for various reasons that we can discuss later if anyone's interested in that. But anyway, the point is you don't have to change source code to change the physics of the simulation. You can just write your own custom plugin. And then here we have a simulation of drones. So this is the same deal. Someone wrote a plugin that basically adds drone flight physics into Gazebo. And so it's the same simulator, the same application. It's just that we tweak the physics using a plugin. So we can have drones fly around this environment. Yeah, so right here, you got some drones flying by, some more drones. It's kind of fuzzy, but I promise they're there. Okay. And this was another competition. So this was a contest to simulate what I believe was, I think it's agile robot, I don't know, it was called ARIAC, which stands for Agile Robot in Industrial, I don't know. Anyway, it's meant to be a very versatile industrial robot simulation. Usually when you have industrial robots, they're very rigid about what they can actually do. So you see this robot's kind of sliding up and down the conveyor belt. Well, usually a robot in an industrial setting is going to be just bolted in place. But the goal here was to have one robot that can serve a bunch of different functions, and that could be a way to reduce costs because robots are very expensive. So if you could get one robot to do the job of 3 or 5, that would be a huge cost saver. And so this was a competition sponsored by NIST, which is a US government agency, the National Institute of Standards and Technology, I think. And so what you're seeing is the entries of a bunch of different contestants that did pretty well at the competition. And all of the source code for this competition is free and open source. So if you want to try to, compete, I mean, the competition is over, but if you want to see how well you can do at this, the source code is all there, ready to go, ready to be used, just like it was for the contestants. Okay, and autonomous vehicles are very hot these days, and those can also be simulated in Gazebo. And you don't even need any special plugins for that. The hardest part is the art assets. I'm sure you can see our little bald men running around there. This video is a few years old, so the art assets are a bit out of date. We have some better human models available in Gazebo right now, but back a few years ago when this was made, all we had were bald, barefooted guys running around. But since then, we've actually hired several full-time 3D artists whose full-time job is to develop free open source art assets that Gazebo users can take advantage of. And those are all available online. You can also have non-autonomous simulations. So just like you could remote control a robot, like in real life, you could also remote control your simulated robot. Like I said earlier, Gazebo is literally just a stand-in for the physical hardware. So if you develop a robotic system that can take human input in real life, it will also work in Gazebo. So what we're seeing here right now is a human was actually using like a electronic steering wheel, kind of like you would use in a racing game, and controlling this simulated car just as they would if it were a teleoperated, like, physical car. Okay, so after all that, maybe you're wondering, how can you get involved? So first, if you're a self-taught beginning user, I would recommend the ROS1 tutorials, and the Gazebo tutorials, and the TurtleSim tutorials, which kind of ties it all together, ties together some of the ROS1 and Gazebo concepts into a single tutorial. I would recommend using Ubuntu 2004. So the latest stable, long-term stable release of Ubuntu, and the Noetic Ninjemi's release of ROS1. So Noetic Ninjemi's is actually going to be the very last release of ROS1 because all of our effort is moving to ROS2, which we can talk about later if anyone's interested in that. But if you are a beginner, I recommend using ROS1 right now rather than ROS2, especially if you're self-taught. And the reason for that, very simply, is that a decent amount of tutorials exist for ROS1, but do not currently exist for ROS2. It's a problem that we want to fix, but it's tricky for us because so frankly, we're all a bunch of engineers, and we have lives, and we need to eat. And so for us to work on something, someone generally needs to pay us for it. We do as much like community, free community service as we can manage, but writing tutorials is a lot of work. And there are so many other demands on us on the actual development of software that's really tough for us to get to working on tutorials unless someone actually goes and pays for us to hire people to write tutorials. And so far, that just doesn't really happen. Not a lot of institutions care about paying for tutorials. So it's a problem. We want to fix it. We're working on strategies to fix it. But right now, the situation is, if you're a beginner, just go ahead and use ROS1. Start learning from there. And what you learn using ROS1 will transfer over really nicely to ROS2 if you ever decide to move to that. And this link has some useful instructions for installing ROS Noetic on Ubuntu 2004. And I mean, it's embarrassing. I'm linking to a website that is not our website. This is someone else's website, not an Open Robotics website. And the reason I'm not linking to an Open Robotics website is I could not find installation guides that are specific to ROS Noetic. But I came across this link, which seemed to have pretty good instructions. This is not like an official endorsement of this website, but what I saw when I visited this link looked good. So maybe go ahead and use that when you, if you decide to install ROS1. How else can you get involved? If you are an active user that wants to improve your own skills, there's the ROS Answers Forum. So if you're struggling with some problem and you don't know anyone that can help you, you can post your, well, first look to see if your question has been asked before. But if it hasn't been asked, then go ahead and ask your question. And if you can, maybe try to help other users with their problems. There's ROS Discourse. That's where you can find in-depth discussions about ROS and just generally connect with the global community of ROS users. And any new developments that come from us, from Open Robotics, will be posted there usually before it's posted anywhere else. There's also the Gazebo Answers Forum, which is the same as the ROS Answers Forum, but focused on Gazebo. And the Gazebo Discourse, which, again, just like the ROS Discourse, but specific to Gazebo. It is rare, but there are some ROS users who don't use Gazebo because maybe they have some other simulator that they prefer. And there are Gazebo users who don't use ROS because maybe they have, you know, some other robotics framework that they prefer. So I think it's important to emphasize that ROS and Gazebo do not try to lock you into each other. They are well integrated right off the bat, but they don't try to force you to use each other. You can use either one with any other robotics or simulation framework that you want. And if you are an expert who wants to contribute to this open source software, I suggest first discuss your ideas on ROS or Gazebo Discourse, whichever is appropriate, because someone might already be working on whatever idea you have, and you know, rather than having a bunch of different people doing essentially the same redundant work, you know, maybe you can collaborate on it. Also, others might have valuable input or guidance to offer. If others, you know, tried your idea before but failed or fell short for some reason, maybe they can help you avoid their pitfalls. And then to actually provide your contributions, you can open issues and or pull requests on GitHub. GitHub is where we currently host all of ROS1, ROS2, and Gazebo. Gazebo for a very long time was hosted on Bitbucket, but it got moved over to GitHub I think about 4 months ago, 4 months ago. And Gazebo also switched from using Mercurial to using Git. And that's all because if anyone's familiar with Bitbucket, they dropped support for Mercurial. So our hand was forced. And the company basically decided, let's just converge on GitHub because GitHub has worked well for us, for our ROS community, and they'll probably work well for our Gazebo community as well. So external contributions are welcome and appreciated on all of our software. So I'd say 90 to 95% of the core ROS and Gazebo development is done by employees of Open Robotics, but we are always happy to accept contributions from external collaborators, especially in the forms of pull requests. Our code review policies might require you to iterate a bit on your contribution before we accept it. I beg for your patience in that process. I understand it might be frustrating if any kind of iterative process may feel frustrating, but I promise we always have the best of intentions, and when we ask for changes, it's because we're genuinely trying to look out for the community in some way. Contributions to documentation are loved and adored. I said earlier, it's really tough for us to find time to work on documentation. If you are if you feel confident enough in your expertise that you think you can help contribute to the documentation, or even just fix errors that you see in our documentation, maybe something's out of date and you figured out, what's wrong in it, please send us pull requests. We will love and adore it. And there's been times where we get applications so job applicants or intern applications from people who can, point to contributions that they made to our documentation. That's huge. That's huge on a job application or an internship application. So it's good for everyone if you can take the time to do that. And that is the end of my presentation. So I'll be happy to take any questions or open the floor to any kind of discussions that anyone wants to have.
Great talk, Michael. So I'm seeing one raised hand. Pallav Bhala, I'm giving you permission to talk. You can ask your question. You can unmute yourself and ask the question.
Hello. Am I audible?
Hello.
Yes.
Yeah, hi, Michael. That was a pretty good presentation. Thank you for that.
Thank you.
Just to give a brief about myself, I've been using ROS for around 2-3 years now. It's a pretty good software for robotic stuff. So my basic question is that throughout my experience with ROS, I have got some idea that I'll come straight to the question. Would you suggest ROS for for someone who wants to go into core robotics field, who aims to be a roboticist or wants to go learn about robotics? I'm asking in the sense.
Okay. So
Sorry, you can continue. Thank you.
Yeah. So as a side note, sorry, not related to your question, but I am hearing that stuttering and cutting out that you guys were saying you were hearing from me. So I might need you guys to repeat your questions once in a while. But what I heard, did you say co-robotics, as in human robot cooperation? Is that what I heard?
Am I audible? Am I audible now?
Yes.
Yeah, you're on. Yep, we can hear you.
Yeah, cool. So my question was that would you suggest robotics to someone who aims to be in the core robotics field or wants to know in depth what I have learned to the beginners who start with ROS? They start mainly with the application perspective. They want to implement an application and they start using ROS, but they don't know in depth what is happening and how it's happening. So suppose I'm using a mapping package. I'm able to see the result, but I don't know exactly how am I how is it working in depth.
Right. Okay, so well, one thing to point out is that any ROS package that you're going to be able to find and download for free is going to be open source. So if you are using a mapping package and you don't know how it works, I recommend maybe going to the documentation for that package, which admittedly might not be very good because documentation is hard. But first check the documentation. Usually the documentation will at least cite some papers that it's based on. So you can try to read those academic papers, usually conference papers or journals. And then at the end of the day, you can always look at the source code directly and try to reverse engineer the source code. And it's not easy. It's definitely not easy. But the information is all there. If you want to have a deeper understanding of how all those things are working. I feel like there was more to your question though that I might be forgetting.
No, I think that answers my question. Thank you, Michael.
Okay. Okay.
Okay, so the next question is from Pranav. You can unmute your mic to ask the question.
Hello. Hi, Michael. It's a very
We can
nice
hear you.
talk. Can you hear me? Hello.
Yep, we can hear you.
Okay. Okay. Thank you. So my question is mostly regarding the job perspective and open source contributions. So uh, right now, like the few things that what I found while searching for internship or job, like most of the company here ask for mostly in C++, but the ROS basically what we do in mostly in Python. So I kind of think like it's a kind of language barrier is there. So and other than that, like and other than company prefer masters or PhD student above the like bachelor student. So how will you prefer to have like masters always in applying for the company? And these are the second question. And the third question is like how to select like a kind of good project to contribute to, or I'm finding it, I have the skill set, but so I was trying to find a project that I want to contribute to, but because earlier I also contributed in Google Summer of Code with BeagleBone. So but in ROS I do not able to find the like I have the skill set, but that's the problem I get. Yeah, I'm not able to find the project in which I'm willing to contribute.
Okay. Okay. So let me just bounce your questions back to you to make sure I heard them properly. So it sounded like the first question was about C++ versus Python, and it sounds like you work a lot in Python, but maybe want to use more C++, or feel like you need to use more C++ for job prospects.
Kind of that.
Okay. Okay. So for that, I think so. One of the really nice things about ROS is that you can choose whether to work in Python or C++. So the individual nodes, you can choose to develop them in either language. So if you
sorry to interrupt, but the thing is
Sure,
that
go ahead.
company prefer like developing on C++ instead of Python. Like most of the company here prefer to have C++ in the development phase.
So is the question about how to improve your C++ skills? Is that a question?
In the ROS, like, is there anything like extra we need to do, or like the thing that we have done in the Python, it's like work fine?
So in ROS, you can use C++ to develop your ROS nodes and your ROS packages.
Okay.
Maybe I'm missing the point of your question though.
Actually, like I don't find a lot of resources mostly in the C++. They all are in mostly in the Python. So, like once I start to make a project, then I face a problem.
I think maybe take another look at the ROS1 tutorials. There should be tutorials specifically about how to use ROS in C++. And I know there are also ROS2 tutorials. There aren't a lot of ROS2 tutorials and documentation, but I do know we definitely have some ROS2, like getting started using ROS2 in C++.
Okay.
I know that exists because I used it myself a few years back.
Okay.
So yeah, maybe take a look for that. Yeah. So on the second question, in terms of so if I remember correctly, the second question was about like degree qualifications, like having a master's degree versus maybe just a bachelor's degree or something, and like job prospects for that. Right. So in my experience, since robotics is such a tough field, it honestly, it definitely helps to have a master's or even a doctorate. That being said, I can say here in Singapore and even in the US, we've, okay, let me back up a little bit. Open Robotics in the US, historically, for a very long time, we would only end up hiring people with masters or doctorates. And there are a few reasons for that. You know, one is robotics is really tough. So like most people with less than that aren't usually going to be qualified to do the kind of work we need to do. The other reason is we've always been a very small company with very limited resources. So it was always difficult for us to hire people in the hopes that they can like train up on the job. Historically, we just couldn't afford that. And then, yeah, okay, those are the main reasons. We would sometimes hire someone with just a bachelor's degree if they had a lot of demonstrated prior experience in robotics, like they did robotics competitions, or you know, they were in robotics clubs and had their own projects that they've been working on. So it's not so much about the degree that you have as it is about your knowledge and capabilities. But most of the time, people that don't have a master's degree or a doctorate historically usually wouldn't have the qualifications needed. Now, that being said, I find that trend is changing. In the US and in Singapore, most of our new hires have been people with just bachelor's degrees, but also they have some kind of experience in robotics clubs or robotics competitions, or just open source software development in general. For our company, specifically for Open Robotics, we really value seeing open source projects, even if it's not robotics. That being said, I don't exactly know whether other companies are going to care that much if you're doing open source projects, but even if they don't give the same kind of bonus to that as we do, it's still a really great way for them to see what you're capable of. It's going to look really good if you have a portfolio of open source software contributions. Like, even if they don't care about the open source community, it's good marketing for yourself. What I recommend above anything else is build up a portfolio of open source projects and or contributions. I think that the industry is getting strong enough that now, like, the demand is getting strong enough that you don't necessarily need a master's degree, but it will help. I'll be honest about that. Having a master's or doctorate will help, but it might not be necessary. So keep your options open, and above all else, focus on having a portfolio. And then I think there was a third question that's escaping me right now. So can you repeat the third question?
Actually, he has written in chat that he has been disconnected. Maybe we can take one another question from
Oh.
Pallav.
Okay.
Yeah, hi, Matthew. I have one more question.
Hello. Okay.
I'm audible, right?
Yep, we can hear you.
Okay, cool. So my question is like a little bit of general, like how, like, is robotics like ROS used in industry, like for product development and all, or is it just like used for
Yes.
prototyping? Like, could you please
So
like?
I apologize. So I apologize for not including a slide of all the commercial products that are using ROS, but there are actually a lot right now. So you'll find a lot of software engineers that say ROS 1 is like unacceptable for like a robotics product, but the reality, and like they have perfectly valid reasons for saying that. They have perfectly valid arguments, but the reality is there are actually quite a few robotics products that are out there making money that use ROS1. And I'm not sure about ROS2. I'm not as confident about that because ROS2 is very, very new and only recently started being like a stable state. So there might not be very many products like out being sold that use ROS2, but there's definitely a lot of commercial interest in it. We have a lot of contracts with private companies that like want to help continue to develop ROS2 so that they can use it in commercial products. Off the top of my head, one robot I know of that uses ROS1 that's really great is the Mirror 100 robot. If you look up, it's just MIR and then 100. I've been using that robot in some of my research and development recently, and it's a completely legitimate commercial product that works really great, and it's using ROS1 inside.
Yeah, great.
There are a bunch of others, but I don't have a list ready on hand. Sorry.
I'm so sorry. Did I interrupt you?
Oh, go ahead. I'm done.
Okay. Like I've been using ROS1 itself. I'm not very I'm very new to ROS2, and I've not actually ported from ROS1 to ROS2 right now. But I have gone through several discussions that have been going on, with the DDS implementation, use of DDS in ROS2 makes it more product friendly, I think. So through the discussions that I have heard. Yeah. That wasn't actually a question. I was just felt like adding. Thank you.
Okay.
Thanks.
So I think we are up on time. So Michael, can we take one more question from the Q&A?
Sure. Yeah, absolutely.
Okay, so we have a question in the Q&A. Could you put some light on cloud robotics from Tavishi Sharma?
Okay. Oh, I see. Q&A. Some light on cloud robotics. I won't pretend to be an expert on cloud robotics, but most of my personal experience is on the AI simulation and mechanics and control side of things. Cloud robotics, I can say cloud robotics is really hot right now in terms of the commercial industry. There's a lot of robotics companies that want to control their robots from the cloud. And I think there's a lot of great reasons to do that. You can have your operators, your robot operators, they can work from anywhere in the world virtually. So that's great. I personally have some concerns about too much dependency on the cloud, in particular uptime. For me personally, I'd like to see some kind of setup where the robots can still operate, even if the internet dies for some reason. And so cloud robotics, depending on how you approach it, might not allow for that. So I always have some hesitation about cloud-based setups, but they're definitely very popular, regardless of how I might feel about it. And I think that's going to be a budding industry.
Okay, so we have another question. I want to do a prosthetic arm simulation, like simulation of servo and string. What can help me, Gazebo or ROS?
Okay, a simulation of, so I guess that means simulating actual tendons as well. So generally speaking, string simulation is actually very tough. That's a very tough constraint to model. Out of the box, I don't think Gazebo really has something that would mimic string simulation. You may be able to pull it off with a plugin, but I think it's going to be tricky. If the string mechanics are like really important to what you're trying to research about the prosthetic arm, you might want to look into other kinds of simulators, or I hate to say it, but maybe even work on your own simulator. It's tough. I'll be honest. Gazebo. So between Gazebo and ROS, I mean, it's going to be Gazebo that's going to help the most for that, because for a prosthetic arm, it's usually not so much a robotic system. But yeah, I'm sorry that's not a terribly helpful answer, but maybe if you post it to Gazebo Answers, like post a question there about the prospect of string simulation in Gazebo, maybe some other user has experience with that. And should I address the basic difference between ROS 1 and ROS 2, or are we out of time?
So can we take one more question, Michael?
Sure. Yeah, I'm good.
Okay. So Pallav, do you want to ask a question again?
Yeah. Hi, Michael,
Okay.
again. Like just a brief one. Like it's just for a general like beginners with robots, or anyhow to anyone who like finds it useful. Like how, what is the procedure that you would suggest to the beginners? Like we have seen like the basic robotics, like to the beginners it's very like intimidating. So how they can
Yes.
actually shift to ROS, like shift their projects to ROS? Could you please like just give a brief idea so that they know the pipeline, maybe from your prior experience or the projects you have. I think you
Okay.
have the better knowledge.
So just to try to make sure I understand the question, are we saying that a robotics beginner has some kind of robotics project that is not based on ROS and they want to try to move it into ROS? Like
Exactly.
make it a ROS-based project? Okay.
Yeah, maybe there are other platforms like MATLAB for simulating robots.
Right.
So what's the main difference for using ROS?
Got it. Okay, yeah, that's a great question. And yeah, I've definitely experienced that because I originally came from an aerospace engineering background where, yeah, everything was MATLAB, right? Like, if you want to make a system, you just make a big honking MATLAB script and, there's your robot, right? So I'd say the first thing is, if possible, and this is it's a big thing to wrap your head around, but start with trying to use good software engineering principles, which if you're not from software engineering, maybe you don't really know what those are, but the most important software engineering principle to try to like bake into your bones from the start is separation of concerns. That means if you have a complex system where a lot of different things are happening, try to take all those different things that need to happen and separate them from each other. Like get them into their own isolated components, and try to figure out where the boundaries between those components should be, so that it's just the minimal amount of communication possible between the different components. Like the minimal amount of information needs to pass between the smallest possible components. And once you figure out what those components are, so for example, vision and like joint control, right? They usually, those don't have to worry too much about each other usually. So try to like break those out into their own separate things. And for each different component, try to write it as a ROS node that sends and receives messages. So like define the inputs and the outputs of those components, and then write that component as a node that sends and receives these inputs and outputs. And then each one of those nodes can be run as its own executable, and they can all just pass the minimal amount of messages between each other. So that's the key thing in terms of migrating. Like, break things down, modularize it, and then for each of those broken down modules, make a node for it.
Thanks, Michael. That was a pretty good answer for this short period of time.
So thank you, Michael, for joining us. We have one query that how we will get the slides and the links which you have just shared.
Oh yeah, I'm happy to share those. I can email them, or whatever. Like, email a
Maybe you can add
sharing
it in
link.
the Slack channel if you are
Okay,
added
sure.
there. Yeah. So
Yeah,
thank you very much for the very inciting talk, talking about ROS, open source, and motivating students to contribute to open source. And maybe we'll have students from these attendees only participating in open source projects and contributing. Thank you very much for joining in.
That would be magnificent. Thank you.
Thank you.
Okay, bye.